can you guys hear me? Hello. Awesome. Okay. So we're going to actually start on new material today for chapter 7. The good news about that is we only have chapter 7 and chapter 8 left. If anybody had any issues with the test, let me know. I checked my emails last night and tried to address anything that was going on. I don't know, it was probably about 9 o'clock was the last time I checked it. So if you had any issues, now's, I mean, not like I'm telling anybody you can't talk, but now's not really the time I can do anything about it. So if you'd send me an email and I'll try to get back to you this afternoon. But I think I addressed everything that was going on up until that point. I think almost everybody was able to take it. If you are right now going, oh my gosh, I was supposed to take my test by yesterday, you might want to send me an email this afternoon. Anyway, I'm trying to manipulate everything that we need to talk about today here on my other screen. Where's that at? Hold on, be patient. I had the PowerPoint here and now I can't find it. So what we're going to be starting on, or what our last two chapters are about, chapter 7 is on what are called confidence intervals, and chapter 8 is on hypothesis testing. So that's the last two major topics that we need to talk about. The nice thing is that once you kind of understand confidence intervals, the whole rest of the chapter is just little changes to which formula you use or which table. Well, actually not which table you use, because we're not going to, I cut out the section where we have to use a different table. So basically it's just a matter of which formula do I use based on what confidence interval I'm doing, but the process is almost the same. And the same thing with chapter 8. Once you kind of understand how to do a hypothesis test, it's just a matter of which hypothesis test am I doing, but the process is the same. So it's kind of identifying what kind of problem you're on. The confidence interval formula looks really intimidating at first, but it's not bad. And the same thing with hypothesis testing. When you first see the hypothesis test, it's a little bit intimidating because it's got several steps to it. But once you kind of get the idea of it, it's not too bad. I can't get my screen to cooperate. Sorry, I'm having technical difficulties here, guys. I've got the PowerPoints now, but now my screen is in some sort of weird mode. Okay, so I'm gonna hopefully pull this over and share it. This is just the schedule. Somebody looked like they were talking, but I was not hearing anything. Maybe they were just talking to someone at their home. Okay, so here's the schedule. And just so you kind of know where we're at, April 26th, of course, was yesterday, and that was when you were meant to take the test by. And then just so you know, I sent out a message and I posted it up and everything, but just so you know that the last day to withdraw now is May 1st, so you can still withdraw up until May 1st is this Friday, right? Yeah. Come on, here we go. Yeah, so that's this Friday. So it was like 2 weeks ago, but they changed that because of the delay, which was part of that was I think they kind of forgot about it, and we were all of us that were teaching were kind of like, hey, did you guys not think about the fact that since we delayed classes by 2 weeks that you might want to delay the withdraw date? So they finally got a date out, and it's May 1st. So that's the last day that you can withdraw with a W, which means you don't get any money back or anything like that, but you can you don't get the grade also. And just so you guys kind of know, if they aren't counting, the state has said, and you might want to double check with an advisor or something on this, because this is not my thing. I'm just passing along info that I heard. We were told that they are not counting your W's this semester against you for the six withdrawal rule that'll keep you from getting like financial aid, that kind of thing, because it's such a weird semester, that the state's not counting that against your 6. So I'm not encouraging anybody to withdraw. I want everybody to stay in, but if you're considering that, just so you kind of know your options, especially, maybe another class or something that want to do that with. All right, so this week we are going to cover chapter 7, so sections 7.1, 7.2, 7.3, 7.4, so hopefully 7.1 and 7.2 today, and then 7.3 and 7.4 on Wednesday. And then next week we'll get through chapter 8, and then the following week is just review and take the chapter exam. So the chapter exam is due by May 17th. So that's, what is that? Over 2 weeks from now, 2.5 weeks from now, something like that. And then that last week is just review and take the final exam. So you can see we're getting really close to the end of what we need to do here. Does anybody have any questions on that? Nope, we're good. Okay. So let me pull up the PowerPoint for today. And if you have a copy of the formulas, the important formulas and tables, it would definitely be handy, especially you may not have printed this yet because you didn't need it. It would be the page after the Z table, or 2 pages after the Z table. I'll show you when we get to one. I'll pull it up. But there's a page that specifically that we use for the confidence intervals and the hypothesis testing. You can use the Z table, but this other page is easier to use. Sorry, my computer's taking forever to open. I think my computer is about to have a revolt. It's like, come on, you used to use your one at work sometimes. How come you're using me all the time now? Okay. So let me pull this up first. I don't think this is in your notes, but just I want to go over this because it'll be helpful to kind of understand where we're headed. So in the 4 sections in chapter 7, oh my gosh. Something is wrong with my mouse too. So that's got to get figured out at some point. There, can you guys see that? We're good. Okay. Hallelujah. All right. So we are going to be talking about confidence intervals, like we said, and also kind of slight aside to this is we'll do how to figure out what sample size you need, but that's a fairly small part of the chapter. You know, maybe 20% out of what we're going to do is figuring out a sample size. So most of what we're doing is confidence intervals. And so in your book, there are actually 7.1 through 7.5. Remember that this is from the 7th edition, and we actually are in the 8th edition. So this is the 7th edition. And in the 8th edition, this is actually 7.2, and this is 7.3, and this is 7.4. We're not doing this section. That's the one that uses a different table, and we're not going to do that. And then in your book, when they did the new edition, they actually added a 7.1, which is like an intro to confidence intervals. So that's what we hope to do today, is like the intro and then confidence intervals for the mean when the sigma is known. So this is what I was talking about, that you have to be able to recognize which type you're doing. So when you're doing, and I know you guys don't even know what a confidence interval is yet, so I understand that. We'll get to that in just a second. But I want to kind of explain like how you're going to know which one you're on. So there's 3 different things that you're going to see. You're going to see confidence intervals for the mean. So the key here is that we're doing a confidence interval for the mean. We're also going to see another type of confidence interval for the mean. And then you're going to see confidence intervals for proportions. So those are the 3 different types of confidence intervals that we're going to have. And the reason that there's 2 different types for the means is because sometimes the sigma is known and sometimes the sigma is unknown. And I'm even going to word that a little different. I'm going to say when only S is known. So there's 3 things that are going to happen. I'll write them off to the side. You're either going to have a mean, or it's going to be asking you to do a confidence interval for the mean, and you're going to have the sigma. Or you're going to be doing a confidence interval for the mean, and you're going to have only the S. Or you're going to be doing a confidence interval for the proportion, and then there's only one type of those. So those are the 3 kinds that we're going to do. The nice thing is this is for both the this process, or these 3 types are the 3 types that we're going to be doing for confidence intervals and also hypothesis testing. So I'm going to say this over several times over the next few days. You're going to be like, yes, 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 we get it. But that's okay. That's better than not understanding. So when we're doing confidence intervals, the first thing you have to decide is, do you have the mean or do you have the proportion? And if you have the mean, you have to decide, do I have sigma or do I only have S? And then the same thing when we get to chapter 8, we do the hypothesis testing. Before you start the hypothesis test, you have to decide, am I doing a hypothesis test for the mean? And if so, do I have the sigma or only the S? Or am I doing a hypothesis test for the proportion? So this determination is the same determination for confidence intervals and hypothesis testing. It's the first thing you have to decide because it matters what formula you use, what part of the table you use, all kinds of those things. So does anybody have any questions on that just in general? Okay, good. One question I have of you guys, what are sigma and S? What's the difference between having a sigma and having an S? What is sigma? And what is S?
Is sigma standard deviation?
Yep. But which standard? They're both standard deviation, actually. So what's the difference?
One's of a sample, one's of a population.
Exactly. So if you have the standard deviation of the population, that's one type of confidence interval hypothesis testing. And if you have the standard deviation of only the sample, then we do something a little bit different. Now, this is important because having the standard deviation of the population is actually better. Like that's a lot bigger, harder thing to get, the standard deviation of a population. But if you don't If you don't have that, you can still do a confidence interval. You can still do a hypothesis test. It's just when you are only getting the standard deviation of your sample, that's not nearly as strong. That's just your sample that you did. It's the standard deviation that you happen to get on your sample. Somebody else could do a different sample and get a different standard deviation. So we have to adjust for the fact that this is only for the sample. So this is stronger than this is. And so this is better, but in reality, a lot of times when you're doing a study, you don't know the standard deviation of the population. In fact, unless there's been lots and lots of study done on whatever you're looking at, there may not be even any other study samples. So this, having the standard deviation of the population is better, but probably less common, unless you're researching something that's been researched a lot. Okay, so let's look at what we have on this and what they look like. I'm really sorry. There is something wrong with my mouse, and every time I try to do a screenshot of the next slide, I have to do it like 5 times before I can get it to work. I thought I had solved the problem. I thought my batteries were just low in my mouse, but that does not appear to be the problem. Okay, so I think I got the whole thing there. Yes, okay, it's a little chopped off, but I got all the words. So in this case, what we're gonna first talk about, like I said before, is just kind of an intro to confidence intervals. So a confidence interval is what we call a point. Well, it's like a spread out estimate of what you're looking at. So before we talk about that, we're going to talk really quickly about what's a point estimate. So we have a point estimate, which is not a confidence interval. Confidence interval is better than a point estimate. A point estimate is a specific numerical value of a parameter. And the best point estimate that you can get for a population mean or a proportion or anything is what you get from the sample. So let's talk about that. So you go out and you take a sample. And again, we're going to talk about averages and we're going to talk about proportions. So averages are like, an average would be, say, I went out and I looked at people, I took a sample of how tall people are, and of the people that I sampled, the average height was 5'10". That's kind of tall. Let's do 5'8". Okay, so I went out and I did a sample of people and I got that their average height was 5'8". A proportion would be, I went out and I sampled people and 60% were taller than 5'4". So a proportion, remember, is a percentage where an average is an actual number. So that's the difference between when we're doing an average and a proportion. So a point estimate is, I went out and I did my sample and I got that the average was 5'8" or 68 inches for people's height. That's the best point estimate of a population, is to take whatever you got for your average for your sample and just say that's what I think that the population is, because it's what I got from the sample. But is a sample going to perfectly match a population? When you go out and do a sample, even if you do everything right, is your sample going to perfectly match the population? No. Okay, I see a lot of shaking, no heads. Okay, so we know, you guys hopefully understand that when you do a sample, it's not going to be exactly right. It's just a sample. We hope it's right. and we hope we've done a good job, but it's not perfect. So what a confidence interval does is a confidence interval says, well, I know that the population's not exactly 68. So let me guess that it's somewhere between 67 inches and 69 inches. So you take and you say, I think the average is actually between 67 and 69 because I got my average to be 68. So this is what's called a confidence interval. And that's what we're going to figure out. How do you build that confidence interval? Like I just went down an inch and up an inch. But the formula is going to tell us how far down and how far up we should actually go to be pretty confident that we got that right. So let's look at the next thing here. Okay, so these next couple things are things that are, they're kind of lead in, but I can tell you they're not really things that we worry about a lot when we're actually doing the confidence intervals. But I'm going to put them up here because I know you guys like to get your slides filled in, get your notes filled in. So here's one. When you're looking for I'm going to put all three of these up at the same time because we can with the way that we're doing it. So these are the properties of what they call a good estimator. The first one is that a good estimator should be unbiased. So what do we mean by that? We just mean that if we were to do a whole bunch of samples, that we should get pretty close to what the actual population average is. So remember, our goal when we're doing these confidence intervals and these estimates is we're actually trying to figure out what's the mean or what's the proportion of the actual population. And so the first thing we want to do is we want to make sure that we're doing something that if we did enough samples and if we did enough samples and enough averages that eventually we should get an unbiased estimate of what the actual average is or what the actual proportion is. By the way, this word parameter, we haven't really talked about parameter. All parameter means what you're looking at. So a parameter could be the mean, the proportion, or it could even be the standard deviation, because we do want to figure out, sometimes what the standard deviation of something is. So, but that's the one we're leaving out for right now. We're not doing that because we lost some time. So we're just going to do means and proportions. So when they say parameter, that's just a generic term for either mean or proportion. Okay. The other thing that, another property that the estimator should have is it should be consistent. In other words, as the sample size gets bigger, this estimator that we're using should get better. So a bigger sample should get us a better estimate. That's all that says. And then the last thing here is it says that the estimator should be what we call relatively efficient. And then that means that of all the statistics that can be used to estimate it, the efficient estimator has the smallest variance. So again, we don't really talk about this for the rest of the section, or the rest of the chapter, so I wouldn't really worry about these too much, but if you want to jot them down, I'm not even going to ask anything like in a multiple choice or anything like that. We really legitimately will not probably see these again. Okay. So let's see what the confidence intervals look like and how we figure them out. I like to always relate these confidence intervals to trying to catch a fish in a fish tank, or even in the ocean or a creek or something like that. Oh my goodness, my computer's making me so mad. Okay. So a confidence interval is not a point interval or a point estimate. It's what we call an interval estimate. So what we're saying is, let's say you have you know, a bunch of some fish in a fish tank. Oh, let's see if I can draw a fish. Don't laugh. Well, you can laugh because I can't hear you. Okay, so there's my little fishy. Okay, so if I was going to reach into this into the fish tank or into the river or the creek or the ocean, and I'm going to try to catch a fish, if all I had when I was trying to catch that fish was my hand or even better yet, say a spear, okay, and I was trying to catch that fish to eat, I'd have to be pretty talented to actually stab that fish with the spear and catch it because it would swim away. But if I was lucky enough to have a net that I was trying to catch this fish with, so again, you can laugh at my thing, but say this is my net. I have a handle and I have this net and I'm trying to sweep into the river or the fish tank or whatever and catch that fish with my net, I'd have a lot better chance of catching it because it's wider. So when you go and do your sample, and again, we'll go back to the reference with the height. Let's say your sample, you know, had an average of 68. If that was the actual height of people, you'd be pretty lucky that your sample got exactly right what the population average was. That would be really lucky. That'd be like throwing that spear at that fish and hitting it right on. But if we said instead, so this is, again, this is your point estimate, okay? And this would be like throwing your spear and you hit right on it, you'd be pretty lucky if that was right. But if you said, well, instead of just saying it's 68, let's cast a net out. And let's say, I think it's somewhere between 67 and 69. That's like your net. Your net is 2 inches wide. And you're saying, I think the average is somewhere between them. So this is what we call an interval estimate. You're not saying a specific point that you think it is. You're saying, I think it's somewhere between here and here. Well, your chances that you actually caught the proportion or the average in there is a lot better. Remember, our average is like our fish, okay? So this fish is our mean or our proportion. To actually catch that fish, that mean with a point estimate is pretty low. But if we spread out and try to catch it with a net, we might actually catch the average in there somewhere. So the estimate may or may not contain the value of the parameter, but the interval estimate is going to be a better chance of catching it than if we were just throwing a spear at it. So what do you guys think? If I threw out a bigger net, would I have a better chance of catching or a worse chance of catching? Again, don't worry about the net getting heavy and not being able to sweep it through the water faster or anything like that.
Better chance.
Better.
But if it's bigger, better chance, right? So if we said, well, instead of 67 to 69, I'll say 66 to 70. I got an average of 80 and I'll go bigger. I'll say, oh, I'm really, really sure it's somewhere between 66 and 70. So the bigger your net means you're going to get a better chance to catch. So a bigger net means a better chance of catching it. So a net gives you a better chance than the point, and an even bigger net gives you an even better chance of catching it. So a point estimate, you'd have to be pretty lucky. That's like throwing a spear. But if you use a net, you have a better chance of catching it. And if you use a bigger net, you have an even bigger chance of catching it. The problem is if you get this net too big, it gets kind of pointless. You're like, oh, great, thanks. People are somewhere between 5'6" and 5'10" on average. Well, how helpful is that? That's such a wide spread. That's 4 inches. Are you really giving me a lot of information? So what researchers have to do is they have to kind of get, they have to decide, do I want more accuracy or do I want a better chance that I'm correct? So they have to decide, do I want to do a smaller interval with a little less chance that I'm right, or do I want to do a bigger interval with a better chance that I'm right? And these are what are called our alpha. So we're going to have like a 90%, we're going to say we're 90% confident, or we're 95% confident, or we're 99% confident. It's nothing magical with those percentages. All they do when they increase the percentages is they're using a bigger net. It just makes your confidence interval wider. So I'm sorry, when you lower the confidences. No, I said that right the first time. When you raise the confidence, all you're doing is widening the net. So by being 99% confident, you're just saying, oh, I'll just do a bigger net. And of course, I'm going to be more likely to catch it. So the next thing that we're going to do is we're going to look at, I believe, hold on just one second. So before we talk about those percentages, I want to show this slide, and this is kind of far down in your slides, but I really think this is the best next thing to talk about. I don't know why they put it so far down in the slides, but it's this picture that looks like it's got a bunch of blue lines on it, and it says 95% confidence interval. If you want to look for it while I fight with my mouse here. For me, it's slide 22, but I know I leave some of your slides out to save you guys paper, so it looks like this one. So if you guys want to look in your slides, it's probably about 10 slides ahead of where we were. Maybe not quite that many.
17, number 17.
It's number 17? Okay, thank you. So somebody said it's for you guys, it's slide number 17. And the reason I want to talk about this is because this is the net that we were talking about. So you'll notice here at the bottom, let me make this a little bigger. You'll notice here at the bottom, it has a mu. Well, why is there a mu? Because remember, our whole goal here is that we're trying to actually figure out the population average. And then when we get to section 7.3, we'll be talking about population or population proportion, but it's the same idea. So we're trying to figure out what is the population average. So when you go and you try to, again, you try to catch that fish and you sweep that net in, if you miss the fish, does that mean it never existed? No, it's still in there, right? You were trying to catch a fish. This is your fish, okay? Your fish is your population average. Let's do a little drawing of it. So your mean is like your fish, okay? And you're trying to figure out where that fish is, what it is. Again, don't laugh at my horrible art skills, especially with a pad. So here's your fish. You're trying to figure out what that average is. Just because you miss the fish doesn't mean the average doesn't exist. So the population average exists, and it is what it is. You trying to catch it doesn't change it. So let's think of our height. So let's say the population average is actually, I don't know, 68.5 inches. Say that's the actual population average of heights, is 5'8.5". I think that's a little tall, but we'll go with it. Okay, so let's say that's the actual average. It exists. You are not changing it by trying to catch it. It is what it is. You're just trying to figure it out. So say when you do your sample, like we did just here a minute ago, and you say your sample got you 68. So this is what your sample got you. You got a sample average of 68. And then you do a confidence interval of, let's say, let's go up at 1.5 inches and down 1.5 inches, so you guys don't think it always has to be an inch. Okay, so say you do a confidence interval that says it's somewhere between 69.5 and 66.5. Did we catch with our net, did we catch the actual average? By saying it's somewhere between 66.5 and 69.5.
No. Or
Well, the actual average was 68.5.
so I guess it is because we got between it because it's between that.
Yep. So if we say that we think the population average is somewhere between 66.5 and 69.5, did we catch the actual average of 68.5?
Yes.
Yes.
Yeah, we caught it. So our net didn't hit spot on because it wasn't 68, but it hit, we got it when we threw our net out. So we didn't hit it with a spear, we didn't hit it with the 68, but when we went down 1.5 inches and up 1.5 inches, we did catch it. So we caught 68.5 in our net of this confidence interval. So now let's look at this next one. So this one looks like, oh, we were really close. So, you know, let's say we did our population, our sample, and we got 68.7 for an average. Was our point estimate right? Is 68.7 the average?
No.
No, it's close though, right? So now let's go up 1.5 inches to say again 69 point. What would that be? That'd be 70.2. Sorry, I'm trying to add in my head here. So let's say we went up to 70.2 inches and down 1.5 inches to 67.2. Did we catch our actual average in our confidence interval between 67.2 and 70.2? Did we catch our actual average of 68.5?
Yes.
Yes. So we caught it again. In fact, we almost hit it with our point estimate. So if you think of these are all that kind of situation where, you know, this one's a little low, this one's a little high, this next one's a little low, just like this one, next one's a little high. But these ones, you know, when we cast our net around what we got, we catch the average. The average, remember, is this black line. So this net caught the average. This net caught the average. What about this net? Did this
No.
net? No. So this one, I don't know. Let's say 1.5 inches, 67. So say we did this one and we got 66.5. And then we are going to go up 1.5 inches. So this is 68. Down 1.5 inches. So this is 65. So with this one, we estimate with our confidence interval that we're somewhere between 65 inches and 68 inches is what we're estimating the average of the population to be. Did we catch the population in our net, or population average in our net that time?
No.
No, we missed. Okay, so this one we caught it. This one we caught it. This one in between we caught it. It's similar to the first one. But sometimes you do miss it. Even having a net, sometimes you don't catch the fish. Remember that you're trying to catch a fish, and just because you have a net, I'm sure that we've all had situations where you've had some sort of a fish tank or something like that, and you're reaching in and you're trying to catch it, and even though you have that net, you miss what you're trying to catch. So this is important, that sometimes, even though we're doing a net, we're still not 100% confident that we caught what we were looking for. So this is why when we do our confidence intervals, a 95% confidence interval means we're 95% sure that we caught it based on our sample size and all of those things, but you can never be 100% certain. Even with the confidence interval, we may miss it. And then the other thing on this slide that's important is sometimes your sample average be the same as your population average? Well, sometimes could you have been spot on?
Yeah, I think so.
Yeah. So sometimes your point estimate would have been perfect. But not very often. And so even though we lose, even though we have to do this range, here we're saying, it's somewhere between 67 inches and 69 inches. And our average that we got from our sample was 68.5. Sorry, this would be 70 inches. So you're saying, well, gosh, that time it was worse. Like we had exactly what the average was. We figured out, or our sample got exactly 68.5. And then we went to this confidence interval of saying it's somewhere between 67 and 70. That's worse than what we had. We said it was 68.5 and it was actually 68.5. But this happens so rarely that we actually hit it, that it's worth giving up that possibility, because most of the time this doesn't happen. Most of the time we hit around it, but we don't hit right on it. So when we do our sample, usually we're a little high or a little low, sometimes way low or way high, and we miss it even with a net. But the idea is if we do this, we'll hit it. You know, this case we hit it 1, 2, 3, 4, 5, 6, 7, 8 times out of the 9. We hit it. But only one time was perfect and one time we missed it. So does that help kind of understand what we're doing with the estimate, the confidence interval, before we actually do one? Does that kind of make sense? Does anybody have any questions on it or anything?
Why is it called 95% confidence interval?
Well, you can change that number, that percentage. And when you do a 95% confidence interval, for instance, what you're saying is, I know there's a 5% chance that even with this interval, I'm wrong. So you have a 95% confidence interval means you have a 5% chance that you missed. So there's a 5% chance of this happening. And if you want to be more confident, so let's say we wanted to do a 99% confidence interval, you just make the net bigger. So this would just be, instead of going up 1.5 inches and down 1.5 inches, you'd go up 2 inches and down 2 inches. So confidence, let me get a clean screen here for this. So now that you kind of understand that process a little bit, if we increase the confidence level, then that also increases the size of the net. That's all that you're doing by increasing the confidence level, is you're making the net bigger. It's not really anything magical. You can't just magically be more confident, and you have to sacrifice how big your net is. So you have to have this big wide net in order to be really confident. So if you want a small net, which is preferable, you want your confidence interval to be fairly small. So if you want to decrease the size of your net or the width of your confidence interval, then you have to decrease your confidence level. So for instance, let's say you want to be 99% confident, you might have to have a confidence interval that's like we said, maybe 66 to 70. But if you want to only be 90% confident, then maybe you could say it's between, whoops, I went the wrong direction, just a second. Then maybe you could say you're somewhere between 67 and 69. So you see, the smaller net is preferable as far as like what you're reporting, that I think it's somewhere, the average height is somewhere between 67 and 69. That's preferable, but you get a lower confidence. You're saying I have a 10% chance I'm wrong. Whereas up here, you only have a 1% chance you're wrong, but look at how wide your net is now. Your net is from 66 to 70, it's 4 inches wide, and it gets less useful. So there's this balance that researchers are trying to do, and they're supposed to pick how confident they want to be before they do their research. So that's kind of the process, is you're supposed to pick it ahead of time. Did that answer your question, Vinay?
Yes, ma'am.
Okay. Alrighty. So let's look at, we're going to go back to the slides that we were on, and we're going to actually learn how to do one of these confidence intervals. And don't panic when you see the formula, because the formula looks very... intimidating. But let's throw this slide up here really quick first. So this just says what is a confidence interval. Oh my darn. So what a confidence interval is it's a specific interval estimate. So like, 68 to 70 or whatever, of a parameter. So it's a interval estimate. In other words, it's going to be between this and this of a parameter. Remember, our parameters that we're going to look at are mean or proportion, which are mu and p. Determined by using data obtained from the sample and by using a specific confidence interval. So we're going to have a sample and we're going to pick a confidence level. They're usually 85%, 90%, 95%, or 99% are the most common ones. So we're going to have a sample, we're going to say how confident we want to be, and then we're going to try to estimate the mean or the proportion with this interval. So this is what the formula looks like. And again, don't panic because it looks horrible when you first see it. So this is the formula for a confidence interval. And let's look at everything that's in it, because everything that's in it we've seen before. Okay. So over here, you'll notice you have an X bar. What is an X bar?
The mean of a sample.
Yep, that's the sample mean. Perfect. Again, if you're having a hard time with these, you might want to still make yourself some little cards or something to try to remember them, because the formula sheet isn't a lot of help if you don't know what the things are they're asking you to plug in the formula are. So X bar is sample mean. Let's hold off on the Z. What's the sigma? We already said that one. That's the
Standard deviation.
Yep, that's the standard deviation of the population. So remember, the first thing we're going to do is we're going to do means with knowing the standard deviation population of the population. So this is the easiest one that we do. And then what's N? I heard somebody say something. I didn't hear what they said.
Is it the values or?
The actual
The
number.
number of
The number of values. Yeah, so you had the right idea. It's the values that you get. It's the number of values you get. So it's the sample size. It's how many samples how many you took in your sample. So if you had a sample of 50 people, your N would be 50. So N is the sample size. And then the other thing that we need is Z. And Z sub alpha over 2 is, we'll just say for now, it's your Z value from and we're going to get that from the table, okay? So for now, we'll get that. So the Z is how many standard deviations you are away from average, and we'll get that from the table. Now, this looks like a really weird formula because like there's no equals in here. There's these less than signs. Well, that's because remember, we're trying to estimate what the average is. So this doesn't change. This just stays in the formula. So your final answer, you're going to have a number less than mu less than a number. So it's going to be, your answers are going to look like this. They're going to have a number here, and then your means in the middle. So this isn't actually something you plug anything in for. That's part of your answer. And then if you notice in the formula, this will make it seem hopefully a lot less intimidating. You'll notice that this left side looks exactly like the right side, except for what?
on the right, you're adding your table value, and on the left, you're subtracting it.
Yep. And it's not just the table value, it's this whole thing. But you're right. On this side, you're adding, and this side, you're subtracting. So like in my examples, I add, one time I added an inch on both sides, another time I added an inch and a half, another side. So it's whatever you're adding. So let's say you know, you add 1.5 here, then over here you're going to subtract 1.5. So this is the same exact calculation. It's just a matter of whether or not you're subtracting it or adding it. So you have your sample size or your sample average, and you're going to subtract something on the left for your lower number, and then you're going to add something on the right for your upper number. Does that make sense? Okay. Holler if it doesn't make sense. And then they are going to give us some of the values here. I'm going to actually not do this. I'm going to actually show you how to get these from the table. So I think it's confusing to leave them off because you're like, where did those magically come from? So I'm going to show you where they come from. I'm going to show you the hard way and the easy way to get them. And of course, you're more than welcome to use the easy way. So I'll show you where they get them from the hard way, but then I'll show you there's a page on in your formulas and tables that gives it to you easier. Okay, so trying to decide if I want to try to keep any of this stuff. I think what I'll do is I'll get rid of this, but then we'll I'll write the formula up here. Oh, before we do that, let's just look at a couple different slides that just kind of explain things. I think you guys are ready to do one of these, but let me just throw these up here. So one thing that we haven't talked about is margin of error. And all the margin of error is it's this number that you're adding and subtracting. So here, let's get some obnoxious color that we can use to circle both of these things. So let's get this bright, this purple. So margin of error that they're talking about here is just this number that we're adding or subtracting. That's not a very obnoxious color. I need a more obnoxious color. All right. So this margin of error is just the plus 1.5 and the minus 1.5. It's whatever we're adding and subtracting. So there's a couple problems in your homework where I think they ask you for just the margin of error. So the margin of error is the z sub alpha over 2 times sigma over square root of n without putting the rest of it in there. It's just that part of it. It's what you add and what you subtract. So it's how far you went up and how far you went down from whatever your sample was. Okay. And then let me see. This is just a little picture that shows, in this next slide, that shows what we mean by a 95% confidence level. But we kind of talked about that a little bit. Okay, so here, a 95% confidence interval just means that this is our net, is 95% wide, but there's still a 2.5% chance that it could be lower than that, and or a 2.5% chance that it could be higher than that. That's where we get the alpha over 2, because you could miss it high or low. So your net could be above your value or below your value. You have about a 2.5% chance that your whole net, this gold part is like your net, is too high, and you have about a 2.5% chance that your net is too low. That's what the alpha over 2 means. Okay, so let's get rid of this whole hot mess that's on the screen right now. And what I'm going to do is I'm just going to write the formula up here. Oh, and then there's a rounding rule. It says when you're computing a confidence interval, round off to the same number of decimal places as the mean. So whatever they give for the mean, that's what you're supposed to use. I'll show you as we do the examples. So before I put the slide up here, let's rewrite our formula. So the formula is that you take the average and you subtract z sub alpha over 2 times sigma over square root of n, and that will be less than the average, hopefully. And then above that, you take X bar, whatever you got for your sample average, and you add Z sub alpha over 2 times sigma over square root of n. So that's our formula. And here's our first example. Like I said, this all seems really awful until you start doing a few and you're like, oh, that's all I do, just plug those numbers in. It's not nearly as bad. But I don't want you guys just playing a game of let's put the numbers in and get this answer that I have no idea what it means. So that's what we were talking about before, is what does this all mean? So now we're ready to actually do one. All right, so it says, a researcher wishes to estimate the number of days it takes an auto dealer to sell a Chevy Aveo. A sample of 50 cars had a mean on the dealer's lot of 54 days. Assume the population standard deviation is 6 days. Find the best point estimate and then the 95% confidence interval of the population. So let's get this point estimate out of the way. I won't even ask this on the test, but there's a couple of your homework problems that do it. The best point estimate is whatever your average was in your sample. So the point estimate is what?
54 days.
54 days. So that's saying if we were just going to throw a spear at it, where would we throw our spear? Okay, we'd throw the spear at 54 days because that's the best we have. If all you want is a single number, I'm going to have to say 54 days is my guess. But we can do better than that if we do a confidence interval. So now let's start plugging our numbers in. We already know X bar is 54, right? So let's plug that in. 54 on this side. We know that on this side we're going to have less than the mean. On this side we're going to have more than the mean. So over here we're going to put a 54 also. So I just put in 54 for X bar and X bar. The Z sub alpha over 2 is a little bit of work, so let's put the other stuff in first. So we're going to subtract Z. Ooh, I need to leave more room than that. Okay, so I'm going to leave a little space there. We'll come back to it. But what's the sigma and the n?
Sigma is 6.
Sigma 6.0, right? Yeah.
Yep, you got it. Sigma 6.0. So sigma is 6.0. This was part of that answer. I'll put that around. But then we also know sigma 6.0.
50 for n.
And then 50 for n. Okay, don't forget the square root over it. So we've got 54 minus something times 6 over square root of 50, and then 54 plus something times 6 over square root of 50. Perfect. Okay. So now all we have to do is figure out what's this Z sub alpha over 2. We get that from the confidence interval. So we know that the alpha is what that's called. We know the alpha is 95%. So now we're going to go figure out what our Z sub alpha over 2 is from the table. Okay. Hold on while I manipulate my 1,000 things I have on my other screen. I don't know how I ever lived without having 2 screens on my computer. Okay, here we go. So there's a hard way to get this Z sub alpha over 2. I'll show you that way first, but then I'll show you the easy way. So remember, we have the population standard deviation, which is a better thing than just having our sample standard deviation. So it's like the best possibility. Is that showing up for you guys? Can you see it?
Yes, ma'am.
Okay, perfect. All right, so the hard way to get this, and you don't even, I would jot this down, but you're only gonna have to maybe do it on a homework problem or two. I won't do on the test, I'll make it so you can do the easy way. But what you do is you say, okay, I want 95. Where can I do this? Oh no, that's not what I wanted you to do. Stop that. I was trying to get it so I could write over here, and it had a heart attack here. See if I can close it and reopen it. Oh, come on, computer. Guys, I'm so sorry. There it goes. Okay. So, I'll be able to annotate on this. Yay. Okay. So what we do is, if we're remember, this is the harder way. So we say, okay, we need to be, according to the directions, we want to be 95% confident. Well, if we're 95% confident, what does that leave on either end again?
Two and a half chance.
Yeah, it leaves 5% total, but it has to be split between the two ends. So it leaves a 2.5% chance on either end. Again, that's why we get that alpha over 2, because I think I wrote alpha is 95%. Actually, alpha is the 5%. So alpha is the 5%, and then we split it between the two ends. So that leaves us a 2.5% chance up here and a 2.5% chance down here. So this is what we have to look up on the table. We have to look in the body of the table. 2.5% means you're at the 97.5 percentile. Again, you may have to do this like on 1 or 2 of your homework problems, and I'll show you an easier way to do it if it's anything normal. So go ahead.
So whatever the percentage is, we take the difference and divide that by 2?
Yep. So 100% minus 95%, that gets you the 5%.
Okay.
And then you split the 5% in half, and that leaves you 2.5%, and that's what you have to look up on the table.
Wait, the 2.5 is the alpha, right?
5 is the alpha.
Oh, okay.
So 5% equals the alpha. But you remember in the formula it says z sub alpha over 2. That's because you have to split it in half. So that's where the z sub alpha over 2 comes from. And so what we have to look up on the chart is 97.5, because we have to come down 2.5% from the top of the chart. Again, remember, this is the hard way. I'm going to show you an easy way. This you might run into a couple on your homework, but most of them you should be able to do the easy way. So what we do is we go to the table and we say, there's 97.5 right there. Boom. So our z for 97.5 is 1.96. And that's the number that we use. So we look here, we say, there's our z value or z percentage that we want, and that comes from the z value of 1.96. And then if it was, say it was 90%, say they said we wanted to be 90% confident, then you would have 10% left over, which would leave 5% up and 5% down. and you'd look on your chart at 95 for 95%. I think we can get them both on here. So 95% is, it's between 1.64 and 1.65. And we always go with the bigger one. So this is where you get 1.65. So that's where those numbers are coming from. But let me show you the easier way to do it. If you scroll down to the very next page, there's this page here that gives you all the most common ones. So all we have to actually do is, why did it not clear that off? Okay, so all you have to actually do is you have to go to this chart, and if we're doing what we're doing right now, which is we're doing what's called a Z confidence interval, and all you have to do is look at this bottom row. So you notice here's the 1.96 that we had, here's the 1.65 that we had, and that is gotten, if you look up above, that's because 1.65 is a confidence interval at 90%. So here's your 90%, you go all the way down to the bottom, 95% go all the way down to the bottom. And we'll talk on Wednesday about when you don't go all the way to the bottom, but for your homework for 7.1 and 7.2, you just use the value that's all the way at the bottom. And this you can use as long as it says 80%, 90%, 95, 98, or 99. You can use this table. The only time you would have to do that hard way is if you happen to run across one in your homework where it gives you something different. But on the test, I'm only going to give you these values. On the test, I will not do anything that's not 80, 90, 95, 98, or 99. So on the test, you can always use this method, this easier method of just going to the bottom. Okay. So these are our values for right now. Okay, so these are the only 5 values that I would ask you to get for a z-value on the test. Okay, so let's go back to our oh Lord, it's here somewhere. Now I need to find my paint. Here we go. There it is. Okay, so let's go back to our formula. So what on our formula, what was our value for 95%?
$1.960, like
Yep.
from the chart.
Yep, 1.960, you are correct. While we're talking about that, even though on your chart it says 1.960, 1.645, I think is the other one, in your homework, most of the time it'll only go 2 decimal places. So on your homework, you'll want to use 1.65, 1.96, etc. Even though the chart gives it out to 3, for some reason on the homework, I think it's because the Z chart only goes out 2 spots. So even though the T chart that we just looked at goes out 3 spots, it doesn't use that. So in your homework, it always goes out 2 spots. Okay, so let's, holy cow. My dog just scared the daylights out of me. Okay, so let's fill in, or let's calculate this now. When I do this, I usually will calculate the margin of error first. So if you've got your calculator handy or even just your phone or whatnot, I always like to figure out this part. Let's use that obnoxious green again. So I calculate this part first. So 1.96 times 6.0 divided by square root 50. So try to get that on your calculator. You should get, I got 1.66.
Me too.
Everybody, is anybody having any problems getting that?
Yes.
You got it, or you're having troubles getting it?
Having troubles getting it.
I got it.
Got it. Okay.
I'm
So
trying
if
to
you're
see-
having problems, try doing the 6 divided by square root of 50 first. And then multiply it by 1.96. You might have to kind of work it backwards a little bit.
Okay, what was the answer you said? It was
I got
what?
like 1.66 when I did it.
Oh, okay. I found my problem.
Okay.
Instead of putting 6.0, I forgot the decimal and put 60.
Oh yeah, that would make it right.
That'll do it.
That'll do it. Okay, so now I put 1.66, but if you remember the directions for rounding were to take this to the same spot as your average. And so actually I can just call this 2.
And it won't be wrong. The
Well,
answer.
no, because that's the rounding rule, is to just round this to the same as whatever your average was. So 54 minus 2 and 54 plus 2. And so we're going to cast our net and say, even though the sample came out 54 days, we're 95% confident. In fact, we went a little bit more than this number, so we're actually probably more confident. But we're 95% confident that it's actually somewhere between 52 days and 56 days that it takes them to sell an AVO on the lot. And if you guys will forgive me for today, I'm going to not put up their nice, pretty finished example just because, well, let me see. If I have problems
Where-
getting it clipped,
Where did the 2 come from again?
I just rounded 1.66
Okay.
because the rounding rule is that you round this to the same as the average, which is the 54. So I just rounded it to the nearest whole number,
Okay.
which let me show you theirs. They're so flaky about this. Like they'll give you this rule and then our book is so flaky about it. Oh yay, it's cooperating. Hold on a second. Now that I yelled at my mouse, now it's decided to be cooperative. Okay, so here's their nice, pretty worked out sample. They tell you to round to the nearest whole, and then as they work the problem, they rounded it to 1 decimal, but then at the end, they rounded it to the nearest whole. So it's like they're not really following their own rule, because if they're following their own rule, they would have put a 2 here. They wouldn't have done it at the end. So
Oh, I see what they did. I would have done it that way myself.
yeah, and I kind of did it here too, but
It's
anyway.
like rounding because there was some problems in the homework from this previous section. It was saying to round certain answers throughout the problem to like 2 decimal places,
Oh,
and then it
then-
would say round the final answer to like 4.
right.
So it's
And
like this one rounding to 1, and then round to the nearest whole.
yeah, so they rounded to the nearest 10th when they were working the problem, but then the final answer, they rounded it to the nearest whole.
As
But-
long as the final answer is rounded to the nearest whole,
It should be okay.
it should be okay.
So what do you guys think? Now that we did one, does it seem quite as bad? I know we were going back and forth to the chart. Maybe the next one will make it feel a little bit better. But that's it. That's a confidence interval. Like we just did a confidence interval, and they get there's a couple little things that they can do to them, but there's not a whole lot they can do to them. So let me get this next one up, and we'll rewrite the formula again.
In a word problem, will it be worded that easily?
Yep.
Okay.
Yep, they just have to tell you what they're trying to estimate, what the sample got. That's about it. All right, so this next one, we're talking about the department store. So if you're looking in your notes. Okay, so it says a large department store found that it averages 362 customers per hour. Assume the standard deviation is 29.6 and a random sample of 40 hours was used for the average. I don't like the way this one worded it because it didn't clarify very much that this standard deviation was from the population, but it is because it says assume the standard deviation is 29.6. So they're saying that's like from before. And then in your sample, 40 hours was the average. So it is what they meant by it. Oh, shoot, I did not mean to do that. Okay, so let's write down our formula and get everything filled in. So we've got x bar minus z sub alpha over 2, which of course this is on your formula sheet in chapter 7, so you don't have to have it memorized, just have to know what it all means. Okay, so let's figure out what everything is. What's our x bar?
Was it a 362?
No,
Is it the 40?
it's the 40. The 362, wait. You're right, I'm sorry. It's the 362. I misread that. So a large department store found that it averages 362 per hour. That's the average. Sorry about that. That is the average. And then what's our sigma?
Standard deviation 29.6.
Perfect. And then the 40 that I was trying to say was the x. What's the 40 actually?
Was that a number?
Yep, that's the number. So hours, you're doing, you're figuring out how many customers per hour. So 40 hours you collected it. So like maybe 1 hour you got 400 customers. The next hour you got 272. And you take all those 40 hours and you average them up. So that 40 is the number of hours you sampled. And then z sub alpha over 2 we'll have to go look up. Okay, so let's fill in what we know. This is 362 minus, we'll look that up on the table. Sigma is 29.6, N is 40. And we're gonna do the same thing over here. So now we have to go look up on the table, and what am I gonna look up on the table?
Go to the bottom for 99%.
For 99% confidence interval?
Perfect. So I'm gonna look at the table for 99% confidence interval, and I'm gonna go all the way to the bottom of the chart. Okay, so yeah, let's pull that up. So remember, you're looking up here at the top, you're gonna go confidence interval, 99%, so that's all the way over here to the right. And then because we're doing what we call a z-test, because we have the population mean, or population standard deviation, we're gonna go all the way to the bottom and use this number. So what are we gonna put in our formula?
2.576.
2.58.
2.58. I know the chart says 2.576, but what we actually are gonna use is, why won't this close? Is 2.58, because that's what the homework does all the time, just 2 spots. So 2.58, and then we're gonna go over here, 362 plus 2.58, and then 29.6 over square root of 40. And that's what we're gonna calculate. Again, I would highly recommend, because sometimes it asks it on your homework, and also just because I think it's better practice, I'd figure out this number that you're adding and subtracting first. So I would figure out that number, and then I would go back and do the add and the subtract. So
I got 12.
you got 12, 2.58 times 29.6 divided by square root 40. Yeah, I got 12.0748 on my calculator. But because this is nearest whole, we can just write this as 12. So 362 minus 12, and then 362 plus 12. What do you guys think? Are you getting it okay?
I mean, if it's worded like this, I feel like I can get this pretty well.
Yeah, but that's it. And I would really recommend, if you guys can, I would do 7-1 and 7-2 before Wednesday if you can. I know everybody's situation is different, kids and jobs, and whether you're working or you're not working, and how many people are running around your house making noise and distracting you. So, but if you can, I'd do it by Wednesday so that you have a little practice on this before we do the little changes. Because yeah, you're right. This is it. For this type of problem, that's all they're going to do. They have to tell you all this info. You plug it into the formula, and you're done. So this is 350 to 374.
Mm-hmm.
So we don't think that the actual average of customers is 362. That's just what our sample got. But we're pretty confident that the average number of customers is somewhere between 350 customers and 374 customers. Somewhere in there. We think that net catches it.
Yes.
There's still a 1% chance that it's down here, and we missed it, and actually a 0.5% chance it's down there, and a 0.5% chance that it's up here. But we're pretty darn confident, 99% confident, that the actual average is somewhere between 350 and 374. And that's one with those, with the customer numbers being so big, this is not really that big a deal to be that far apart. If we were talking about, blood pressure or something that was more affected by being too high or too low, we might want to go with a little bit less percentage and a narrower net. All
I
right.
have a question real quick, because you mentioned the easy way and then the hard way. Will we actually, how do I ask this? We can just go ahead and just use the easy way throughout homework, right?
Yes.
Because I know you said we'll be able to do it on the test, but the homework will just, okay.
Yep. The only time is there may be 1 or 2 on your homework where they'll give you a weird percentage. Like they might say 92% or 85% or something like that. So if it's not on the T-chart, on the easy one, if it's any other number besides one of these, you'll have to do it the hard way on your homework. But I won't do that on the test. On the test, it'll be one of those 5.
Gotcha.
So,
And what's the main difference? I kind of was confused about the main difference for the hard way. You go to the Z chart.
yeah, that's the one where you have to go to the Z chart. And so, like, if they gave you, I don't know, on your homework, let's just throw out a value. I don't know why I've got this extraneous junk up here. I don't know where that came from. What is this doing? Okay, so if on your homework, let's say instead of one of those 5 easy ones, let's say it gave you, like I said, let's say it gave you 92%.
Okay.
Then you'd have to use this because you can't, there's not a 92% on the T-chart. So you'd have to go and do your, 92% means how much is left over.
Divided by 2.
Yep, so 8% is left over, right?
Mhm.
Which means there's 4% up here and 4% down here. And what would this percentile be if we're 4% from the top?
So it'd be 1 minus, or do we do that thing?
Yep, 100 minus 4% would be
0. Oh wait, you look at the chart.
no. We have to figure out what to look at the chart for. So if we have 4% left at the top, what percentile are we at?
Would that be 96%?
96%. So this is what we're going to look at in the chart. We're going to look for 0.96, which would be right here.
Okay.
So 1.75. So you'd have to do your Z sub alpha over 2 is 1.75. But again, most of your homework problems you're still going to be able to do the easy way on the chart. There just might be 1 or 2 of them that you have to do that. And it's kind of nice to know where it comes from, but it's sure nice not to have to do it all the time. If it's any of these, I mean, we only had to do that because this was 92 and 92 is not up here. If it's 80, 90, 95, 98, or 99, you can just go all the way to the bottom and use these numbers here.
Okay. And then 95, you look at then at the Z number to get the
Yeah.
Z.
For what
Okay.
we're doing for right now, we're gonna talk a little bit more about this chart on Wednesday. But for the homework problems for 7172, you can just go all the way to the bottom here.
Okay.
You can
Fine.
get these values because these are all what are called T values. So you can use these numbers here. I'm sorry, not T values, Z values. So you can use these numbers here. Okay. Hold on, let me see. Okay, so let's look at, do we have another example or is that it? So they have the nice, pretty version of what we just did here. And I chopped it off a little bit, but we'll go with it. So here's their nice, pretty version. It says, here's the work that we just did, same work. And then it says, hence one can be 99% confident that the average number of customers that the store has is between 350 and 374 customers. So that's the exact same thing we got. And then the only thing that we have left in this section, I'm not going to worry about that one. There's the one with the curve, but I'm not going to worry about that one. We already did the one with the little blue bars. Oh, and now they're just working on how do you find that number, but we already know how to find that number because we already did that. So I don't want to do those. Let's go up and we'll do this one with the credit union assets, and I'm gonna pull part of it out. So we'll do this one last example and then we'll call it a day. So here's a question. In this question, it gives you raw data, but I didn't do any in the homework that give you raw data. So in the homework, it'll already give these to you. So I'm going to write down, I'm going to cheat and look at the next slide and write down what they are. So the following data represent a sample of assets in millions of dollars of 30 credit unions in southwestern Pennsylvania. Find the 90% confidence interval. So if you were doing one of these in your homework, it would have to give you the average. So the following data represents, they would have to give you the average. So the average of that data is 11.091. And then the sample or the population standard deviation is 14.405. So these would have to be given to you. Okay. It would say, if the assets of credit unions in southeast western Pennsylvania had an average of 11.091 from your sample, and you knew that the population standard deviation was 14.405, figure out the 90% confidence interval. It would have to give you that. Okay, so let's do one more. So what are we going to fill in for X bar?
11.1? 10?
No, do what they give you.
Oh, okay, 11.
11.091. You have to actually do what they gave you.
Okay.
So in this one, we always round this error off of what the average was. So they gave the average to 3 decimal spots. So that's what we're going to use. Okay, and then what's the sigma?
14.05.
Yep, so that's the sigma.
405, my bad.
And then the N was, if you look at the table or the picture that they gave there, it was 2, 3, 4, 5, 6, 7, 8, 9, 10. There was 30. Oh, it's right there. I don't know why I just counted. Okay, so this is 30. So square root of 30. And then do the same thing over here, 11.091. We have to look up Z. Sigma is 14.405 over square root of 30. So if you have your chart, go and look up Z sub alpha over 2 for this problem. I won't say anything quite yet. If you don't have your chart, here is the chart. Whoops, I'm on the wrong one.
What was the percentage on that one again?
90% confidence level. So hopefully you're looking at 90% here, and then you're going all the way down to the bottom and using 1.65, because your homework only goes two decimal spots. So don't use 1.645, just use 1.65. Okay, so 1.65 from the chart.
Where did the 30 come from? The N, where did that 30? Oh, I see, credit. Okay.
Yeah, it's how many credit unions they sampled. And then I would do this part first.
4.339, so 5.
Yeah, and remember, we're always going to match what this one is, so go out 3 decimal spots. The other 2 we just did had whole numbers there. That's why we rounded to the whole number, but this one has 3 decimal spots. So we're going to do
4.339.
Yep. I haven't even typed it in, so I'm taking your word for it for the moment.
Yeah, I got the same.
Yeah, that's what I got.
Okay. 4.3394, which would be, yep, 4.339. And if it asks on your homework, that's the margin of error. So 11.091 minus 4.339. And then over here, we're going to do 11.091 plus 4.339. Remember that what we got on our sample, that's kind of like our middle, and then we just go down from there and up from there. So
I got 6.752 and 15.430. 752.
Okay, and then
15.430.
where did I think I was going to get 11 again here? Okay, 15.450.
I got 30. I don't know if anybody else got that.
I haven't had time to type it in. You guys just tell me, what is it? 15 point what?
30 or 0.430.
430. Okay. So now let's look at this one and talk about what the researcher wanted to do and what happened. So the researcher wanted to be 90% confident. That's not a real high confidence level. I mean, you saw on the chart, 95, 98, 99 are also really common. But even at only 90% in this case, you have a width here. Look how big of a difference. This is in millions of dollars of the assets at a credit union. So we're saying we're only good. We only got as good as saying that the average assets at these credit unions is somewhere between 6.752 million and 15.430 million. I mean, that's a huge width for when you're talking millions of dollars of an average. So why did that happen? Well, our 90% wasn't super high, but our average or our sample size wasn't very big. So another thing is, remember, you're dividing by the sample size. So let's match these things up before we go, and then we'll call it a day. Oh wait, did I miss? Hold on, we might have to do one more thing before we call it a day. Oh yeah, we have to do one more thing. But anyway, so before we're going to do one other thing, but before we do finish up with confidence intervals for the day, there's two things that can happen. If you increase your sample size and or you decrease your percentage, then what that is going to do is it's going to make your net smaller. It's going to make the width of this smaller. So if you're okay with a lower percentage or you have a nice big sample, that will make your net smaller. On the other hand, if you try to make if you have a really small sample size or a smallish sample size, that's not good. And or if you want to have a really high percentage, then either of those things is going to make your net get bigger. Because to be confident, we have to have a wider net, more confident that you're going to catch the fish, or you have to have a nice size sample. So if you have a small sample, that's bad. Or if you want a really high percentage, that makes things more complicated, and that's going to make your net bigger. So in this case, even though the percentage wasn't terribly high, the fact that they had a pretty small sample made this this net bigger. So anyway, this as far as like questions on the test, like multiple choice questions on the test, that's a possibility for a multiple choice question on the test. If I say, you know, what happens to the width of your interval if you make your sample size bigger? And the width of your interval would get smaller, because smaller is better. Bigger sample size, smaller net, they're both better things. Okay, so before we do need to do one more thing before we quit for today, so that you guys can actually do your homework if you want to. The last thing that we're going to look at is, what do we do, or what does the researcher do ahead of time if they want to keep the if they want to know how big of a width that they want. So say ahead of time that they already know, I don't want to go up and down any more than this certain amount. They can make that decision ahead of time by picking the correct sample size. So here's the formula for it. So if you know ahead of time that you have a desired error, remember that's how much you go up and down. So you have a desired E that you want to go down and up, then you can calculate ahead of time how big of a sample you need. So let's see what one of these looks like. And then we will, for real, call it a day. And we'll get into the other two types of tests for proportion. And if you don't have the population standard deviation, we'll do those on Wednesday. But we've done, honestly, if you understand what we did today, that is the bulk of chapter 7. And so, and then remember, we only have chapter 8 after that. So, all right, so here's our sample. It says, a scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. So he's saying when he does his calculation, he wants this to go no more than down to, and this to go no more than up to. He doesn't know his average yet because he hasn't done his sample, but he's saying when all is said and done, I don't want to go down more than 2 or up more than 2. So he wants to be accurate within 2. And so what he can do to not manipulate it, but to guarantee that, is he can put into this formula and figure out how big a sample he should take. So in this case, what is our sigma? From previous studies, the standard deviation was 4.33. Yeah, so that's our sigma. So 4.33 is our sigma. Our error is what?
2.
2. Don't forget to square it. That's a common mistake in these problems. So don't forget to square. And then we have to find our z sub alpha over 2 for 99%. So if you pull up your chart, so 99% is the one all the way over on the right. Come on down here to the bottom. That's that 2.58 number. Remember, you're going to use these same 5 numbers a lot. So 2.58. And then you plug that in there. So 2.58 times 4.33. It equals, divide by 2, and then square it. You should get about 31.2.
I did that wrong. That's weird. I went ahead and did the multiply the top 2 numbers. I squared it and then divided by 2. And I got twice the number you just got.
Right, because you really should have divided by 4 because you didn't square the 2. So that's why. Okay, so
31.2.
okay, perfect. So what we have now is this is a minimum sample size. So the n is 31.2 minimum. You don't want to go any smaller than that. That is the minimum sample size. So what is he going to do in practice? I can't go down to 31, even though 31.2 rounds to 31. This is the minimum sample size. So if I go down, it's going to be too small. So he's going to go up. So these always get rounded up, no matter where they're at. Whatever value you get, if it's not a whole number, go up to the next one. Because 31.2
So if it were
is
31, sorry.
it was 31. Go ahead.
I'm so sorry. If it was already 31, we wouldn't have to like move it or anything.
Yeah, but that doesn't happen very often that it comes out exact.
Okay.
So even if it came out to be 31.02, you'd still round up to 32. Or 31.01, you're still supposed to round up to 32.
Thank you.
Yeah, so whatever you get on these, just take it up to the next number.
What would this equation be called?
It is the formula for, hold on just a second. Formula for minimum sample size needed. Here, let me put the whole slide up here. I only put the formula up before, but I'll put the whole slide up. Oh, if my mouse will cooperate with me.
It says the sample size for means on the chart.
Yeah.
On the formulas thing.
Here's what the whole slide actually looked like. I just chopped out the formula, but here's what it looked like. It's called the formula for minimum sample size needed for an interval estimate. And in layman's terms, what sample size do you need for a specific desired margin of error? So on your homework for chapter 7, it's pretty much going to ask you either what's the confidence interval, or it's going to ask you what sample size do you need. I would guess these are at the end of the homework. And the difference is it's not going to say find the confidence interval. It's going to say how big of a sample do you need. So you'll notice on this slide, oof. I'm always on the wrong thing here. Anyway, on the slide it says, at the very end question, it says how large a sample is required. It doesn't say find a confidence interval for this. It says how large a sample is required. So how large a sample is required is asking you what n do you need. Does that make sense? So it's saying, what is n? And so that's how they're going to be different. Okay, I'm going to close this up. My whole writing screen here has just become a disaster area. Okay, there you all are. All right. So, does anybody have any questions before we call it a day? No. Okay.
So are we going to do exam, what is it called?
Oh, the corrections? Oh, so has anybody gone and looked at their tests today?
I didn't
To see if
look
it
at
gave you the, okay. So I'll just say this, but somebody has to let me know if you can't see your answers to your exam, because I think what you can do now, because it's past the due date, I think you can go in and look at what questions you missed and what the correct answers were. I'm almost positive. So because it was due last night, like you couldn't do that before, but I think now you can. So if I'm wrong, let me know, because remember, doing these tests online is new to me too. Like we never did that before. We always said if you missed the test, you had to go to the testing center. So I've never done these online tests before. So if you can't see your mistakes, let me know, and I'll see if it's because of a setting or something. But just on a separate piece of paper, just do exactly what we did before. Just write what your mistake was, what the correct answer is and why, and then work out a similar problem. And just write that out on a piece of paper, and then I'm going to have to put a Dropbox or something up for test corrections. But then you can just put them in the Dropbox. You can take a picture of them and put them in there. You can type them out and just put it as I don't care, as long as I can read them. I don't care how you do it. And just make sure you do the 3 parts. What did you do? Explain what you did incorrectly. Work the problem out correctly, and then do a similar problem. And you could do different numbers or whatever you want.
Okay, sorry. Yeah, I forgot what you. Okay, so explain what you did incorrect, and then.
Yeah, you know what? I'll put the directions, because I'm gonna have to make a Dropbox, and so I'll put the directions in the Dropbox.
Okay.
But it's explain your mistake, work the problem correctly, and then do a similar problem.
Right.
So,
okay.
But somebody please let me know if you can't see your mistake or the correct answers. What's up, Brittany?
You said when we write the similar problem, I know you said before we can use like examples from the problem from the book or homework problem.
Yep, anything you want.
When you said the changing the numbers, could we use that same, is that just using the same problem, just exactly that, different numbers?
Yep, you can just take whatever was there and just say, what if the average was this and the standard deviation was this instead, and then just rework it that way. The only thing nice about using a former problem is you can check and make sure you're right. But the point isn't just copying it. So what would be nice is to write down the problem, put it aside, work it out, and then check and see if you got it right. But I can only monitor so many things with so many students. So you do what you think works best for yourself. So.
I can't.
D2. Oh, hold on.
I'm trying to go look at my exam and it's not letting me.
Yeah, same. I'm on.
So
right
it's not working for you either?
No.
Okay. I'll go see if that's some setting that I can change. Shoot, I was really hoping that would work.
It says you have to use the lockdown browser to look at your results.
Oh.
Oh, so you might have to get into the lockdown browser to do it.
When I was taking the test, I clicked the formula chart and it would not let me exit it. So I had to literally exit my exam to get back to the questions. I don't know.
Did it let you get back?
It ended up, yeah, it let me continue, but it was really inconvenient for me.
I had the same issue. Now that you're talking about it, I had the same issue. Exit out of the test and then.
Do y'all have y'all's little chart that came with the book? I just used mine on the exam.
Some people didn't buy a hard copy.
I don't have the book.
I didn't buy a hard copy.
Yeah.
Some people only bought the access, and so then they don't have it. So I don't know what else to do about that other than to try to print one if you can. If you want to, like if you have two separate, like if you want to take a picture on your phone and have it on your phone, that's fine. I really don't care. So like if it was giving you problems, feel free to like take a picture of it and have it on your phone. Or if you don't, I know a lot of people don't have a printer at home. So you can't just, oh, I'll just go print one. It's like, I don't have a printer. That doesn't, I'm not going to tell you have to go buy a $60 printer just to take your test. So, I feel bad. I wish I could like mail you all one, but that's a little unreasonable too. So, that's the, yeah, I would just take a picture of it or a screenshot of it, have it on another screen, or, oh, you can't have it on the other screen because of the lockdown browser.
I was having problems
literally
yesterday.
be on a different device. So
I was having problems yesterday at first trying to get into it. It kept telling me I had to close my Skype, I had to close this, I had to close that, and half of it I didn't even know I had on my computer.
Well, see, now it's made your computer faster, so you had all those things running and you didn't even note it. So, well, somebody let me know if using the lockdown browser you cannot see your results. Okay, somebody just shoot me a. I know Leo was saying he's trying to get, so Leo was trying to get in. So if it doesn't work, like if it will not let you see them, let me know, and I'll go try to figure out if I can change anything. It only lets me change so many things.
Okay, then I'll try to open it up again and see if it will let me.
All right. And shoot me an email. You guys have a great day. I'm going to go do yard work. Yippee. I'll talk to you later.
All right. Good luck
All
with the
right.
yard work. Okay.
Thanks. Bye, guys.
Bye-bye.